to teach you about the ratio test. So what is the ratio test used for? It can be used for 1. Finding divergence and convergence. So if the series is convergent, it is also absolutely convergent. And the second thing that it's used for is for finding the radius of convergence and interval convergence for power series. So the ratio test has 2 parts to it. 1, if limit of n approaching infinity, a n plus 1, a n in absolute values equals L, which is less than 1, then the series is absolutely convergent. And 2, if it's greater than 1 or it equals infinity, then the series is divergent. However, if it equals 1, then the ratio test is inconclusive, which means that no conclusion can be drawn about the convergence or divergence. When asked to determine convergence or divergence of a series with a factorial in it, it is convenient to use the ratio test. So let's do a practice problem. So to do this problem, you take the limit of an plus 1 over an and see if it's less than 1, equal to 1, or greater than 1. So first you would write out an plus 1. Also, because it's absolute value, you can just ignore the negative 1 to the n power. So now, because you have to divide the an plus 1 by an, you just flip the original fraction, and you get this. So with this, you can cancel out a lot of things, and eventually you can take the limit of it. So, for example, there's a 2n plus 1 here, and a 2n. So because 2n plus 1 is just 2n times 2, you can cross out the 2n. So cross out the 2n. And then you want to get rid of the factorials, so you can rewrite n plus 1 factorial as n plus 1 times n factorial, because n plus 1 factorial is basically n plus 1 times n minus 1 times n minus 2 ... So if you rewrite n plus 1 factorial as n plus 1 times n factorial, you can cancel out the n factorials. So when you simplify it, you can get this. Using your knowledge of taking limits to infinity, you can divide the numerator and the denominator by the highest power from the denominator. So then I would divide this whole thing by n cubed, and also the denominator by n cubed. So after you cancel out and simplify, you get this. Now you can take the limit to infinity. So if you plug in infinity for all the n values, this cancels out to be 0. If the numerator is 0, then the whole thing is 0. And because 0 is less than 1, this series is absolutely convergent. You can also use the ratio test even when there's no factorial in the series. So for example, if you have this problem, the an plus 1 would be, and then the an would be the original series, but because an plus 1 is divided by an, you have to multiply an plus 1 by the reciprocal. So then again, you can cancel out things, so the 4n goes away. Then you would get 4 times n squared plus 2 over the square root of n plus 1 squared plus 2. And then you can separate the 4 from the rest of the fraction, and then you can simplify. So then again, using limits to infinity, you can simplify this and divide the numerator and the denominator by n squared. So because these are both to the second power, when you divide them you get 1. So then the limit would be equal to 4 times 1, which is equal to 4. And because 4 is greater than 1, then the series is divergent. The second thing that the ratio test is useful for is when you're trying to find the radius of convergence and interval of convergence. So let's do a problem. So if you were given this series, you would again use the ratio test to determine the radius of convergence and the interval of convergence. So first, you would take the limit to infinity, and then you again do the an plus 1, and then you would divide by an. Then again, like before, you can simplify by crossing out. So 2n plus 1 is the same thing as 2n plus 2, so you can cancel out the 2n's. And because there's an x here, and you're taking the infinity from n, you should isolate the 4x plus 1 squared. So then afterwards you can simplify, and then take the limit to infinity, so you would divide the numerator and the denominator by n cubed, and because they're the same power, then it equals 1. So then the limit would just be equal to 4x plus 1 squared. So using the previous rule from before of determining convergence and divergence for using the ratio test, you have to compare this answer to 1. So because we're trying to find if it's convergent or not, you do less than 1. So then you want to try to get the 4x plus 1 into an x plus 1 or x plus something form. So you can take out the 4 and then divide by 4 to get this. So then 1/4 would be your radius of convergence. Now you want to find the interval of convergence. So you solve for x using the inequality. So now that you have the values 0 and -1/2, you want to check them to see if they're included in the interval. You can do this by plugging in the x values to the original equation. So now you have to determine if this is convergent or divergent. So using the comparison test, it converges. So now you have to check -1/2. So you plug in -1/2 to the original equation. So because this is a -1 to the 2n, you can use the alternating series test to determine if it's convergent or divergent. So by the first part of the alternating series test, you can see that the series is decreasing because the denominator gets bigger, which means the whole fraction gets smaller. And then by the second part, because the limit to infinity is equal to 0, then the whole thing converges by the alternating series test. So because the two values 0 and -1/2 give convergent series when you plug it back in, the interval would include 0 and -1/2. So the interval would be a bracket -1/2 to 0. Here are some helpful tips and things to remember. So the first one, factorials. So you have to remember that n plus 1 factorial equals n plus 1 times n factorial. Another thing that you should remember is your exponent rules. So if you had like 2, 6 plus n, that's the same thing as 2 to the 6th power times 2 to the n. And another thing you should probably remember is the absolute value bars. So if you had a -1 to the nth power, you can just ignore it because -1 is -1. So then if you're finding radius of convergence or interval of convergence, or if you have an x, then you should separate the x from the n values to make things easier. In conclusion, the ratio test is a really simple and easy test that you can use to determine convergence and divergence.